Our next video is on measure of variability. Measure of variability is a measure of a variety, or variability is a way of describing how spread out the data is. It can also be described as how much the data deviates from the center. The interquartile range, and we're going to talk about this down here too in a minute in the vocabulary that I have. The interquartile range, or the IQR, is a measure of variability that splits the data into 4 equal-sized quartiles. It represents the middle 50% of the data. The IQR can be found ordering the data from least to greatest. Finding the median. Finding the median of the lower and upper quartiles. And then subtracting to find the IQR, which is the interquartile range. All right, before we do any of this, I want to, share some vocabulary that we'll use. All right, so you've got the minimum number, which is the smallest number in the data set. The first quartile, which is also known as the lower quartile, is the median of the lower half. The median is the middle number. The third quartile, or upper quartile, is the median of the upper half. The maximum is the largest number in the data set, and then the interquartile range is the third quartile minus the first quartile. So we're going to look at what we have here as far as a problem. The data set below represents the number of animals in different exhibits at the zoo. And then we have this data set. Write the data from least to greatest. So we're going to say 15, 18, 48, 52. We got to put 27 in here. Okay, let me fix this size. So I left out a number. Let me fix this. Let that dry a minute. But anyway, you would order them from least to greatest. And then we have 27. So I'm going to pick up. And 7, 48, 52, 86, and 103. Make sure you don't skip any, like I did. All right, so we have them in order from least to greatest. What is the minimum number of animals? So the minimum number is here, which is 15. What is the maximum number of animals? Which would be 103. What is the median number of animals? And that's when we mark out, like we did before. I'm going to underline this time because we're going to need the numbers again. So the median number of animals is 48. What is the median of the first half of data? So the first half of data is going to be these 3 numbers right here. And if we mark 15 and 18 out, the median of the lower half is 18. And then if we're up on the top and we mark out 52 and 103, the median is 86. And then your interquartile range is going to be 86 minus 18, and that equals 68. So it's real simple in how to do that. But you do have to put them in order from least to greatest. All right, and down at the bottom of that page is mean absolute deviation. I love doing this. One way to describe the variability of how spread out a data is by using the mean absolute deviation. Mean absolute deviation is the average distance that the data points in a set of data are from the mean. A MAD close to 0 means that the data values are close to the mean. So the math at close to 0 means that the data values are close to the mean. All right. Steps to calculate the mean absolute deviation. And I'm going to give you, we'll fill this in, but then I'll show you on another sheet of paper how to do it. So the first thing to do would be to find the mean of the data set. And then you find the distance from each data point in the mean. And then we find the average of those distances. Okay, so we have this set of data. We're not going to use this table. We're going to mark this one out. So we're not going to use this. On notebook paper or wherever, we're going to use this table right here, where that you have the data, the mean, the answer that you get, and then the positive value. So the first thing we do is we're going to list our data in the data table, okay? And I said to do them in list the data column 1 from least to greatest. All right, so I'm going to list it and then I'll show you. So we've got 40, 42, 48. There's a 39 at the beginning. Okay, it's not going to be in order, but that doesn't matter really for this. 39, 52, 60, and 62. So that's 1, 2, 3, 4, 5, 6, 7 pieces of data. 1, 2, 3, 4, 5, 6, 7. Okay, so y'all can see that. And I didn't put 39 at the top, but with this it's okay unless you're finding the median, and we don't. So we're going to add these up on the calculator. So we've got 40 plus 42 plus 48 plus 39 plus 52 plus 60 plus 62. That's 1, 2, 3, 4, 5, 6, 7. And we add those up, we get 343. So I've got 343, and I'm going to divide it by 1, 2, 3, 4, 5, 6, 7. Divide it by 7. Come back here. Divide by 7. And that gives me 49. So if we go on the first sheet, the mean of the data is 49. So what you would do here is you would put 49 all the way down this data table. Like that. Okay. And then you would take the data right here minus the mean, and it's going to give you an answer. So if we do, and you have to do it like it is. So if we did 40, 40 minus 49, that gives you a negative 9. We'll put a negative 9 here. 42 minus 49 equals -7. 48 minus 49 is a -1. 39 minus 49 is -10. 52 minus 49 is 3. 60 minus 49 is 11. And 62 minus 49 is 13. So we're down to number 4. We placed the answers in column 3. All right, then it says change all answers in column 3 to positive values and place in column 4. So a positive value of -9 is 9, -7 is 7, -1 is 1, -10 is 10. Then we have 3, 11, and 13. So we're going to add those up. We've got 9 plus 7 plus 1 plus 10 plus 3 plus 11 plus 13. And that gives us 54. All right, and then we added 7 numbers. So 54 divided by 7 is equal to 7.71. So our mean absolute deviation for that data set, if we round it to the 10th, is 7.7. It's 7.7. So I took this, subtracted this, and got this. And I did it all the way down and changed all the numbers to positive values and then calculated the mean of column 4. And that gave me my mean absolute deviation. So the mean absolute deviation is 7.7. And we listed the distance in our worksheet there. And to explain what 7.7 means, that means that the average distance that each number is from the mean of 49 is 7.7. So it means the average distance so the mean of 49 is 7.7. All right, and then down here to the bottom, number 3. Mrs. Johnson recorded the number of pages 5 of her students read that day. Complete the blanks below in order to make each statement true. All right, so one, we got to put them in order from least to greatest. So we've got 18, 19, 20, 21, and 22. All right, the minimum number of pages read is 18, and the maximum number of pages read is 22. All right, if we're looking for the interquartile range, so if we got, here's the median. All right, so we split that data. There's only 2 numbers, so we would add these 2 together. So 18 plus 19, and we get 37, and divide that by 2, you get 18.5. And then 21 and 22 gives you 43, and divide that by 2, you get 21.5. If we're looking for interquartile range, it's 21.5, the upper quartile minus the lower quartile, and that gives you 3. So the interquartile range of 3 means that there is a small amount of variability in the number of pages read. The average distance that each number of pages read is from the mean is. So we would have to do a mean absolute deviation from there. So if we've done that, and we took another table, and we listed that data, we would have 18, 19, 20, 21, and 22. We would add those pages up. So we got 18 plus 19 plus 20 plus 21 plus 22 is 100. We'll divide that by 5 because that's how many numbers we added up. And that gives us a mean of 20. So we're going to put 20 here all the way down. 18 minus 20 is a negative 2. 19 minus 20 is a negative 1. 20 minus 20 is 0. 21 minus 20 is 1. And 22 minus 20 is 2. We're going to all positive values over here. So we've got 2, 1, 0, 1, and 2. We add those up. We get 2, 3, 4, 5, 6. 6 divided by 5 is 1.2. So the MAD for that set of data, that part of data is 1.2. So we come back in here. The average distance that each number of pages read from the mean is 1.2. Since the mean absolute deviation is small, a small number, this means that the number of pages read are close together. And of course, 18, 19, 20, 21, and 22 are close together. If you need any help with mean absolute deviation, let me know.